Hello students, welcome to the second part of lesson 8-4. We're going to continue our discussion in this video on slope, the slope of a line in a graph. And we're going to just real briefly talk about how do we find slope from an equation, and then also how do we find slope from a graph of the line, okay? So the key thing to remember is that when we're finding slope, it all comes back to the formula that we looked at in our last video. Okay, so that formula m equals y2 minus y1 and so on. Okay, so I'll remind us of the formula. Remember that m stands for slope, although we're not 100% sure why that is. We always put the y values on the top, y2 minus y1. Remember, those are just the y coordinates from the 2 points that we were given in our last video, over x2 minus x1. Okay, so this formula is going to be how we find the slope of a line from an equation for now as well. Certain forms of equations, if equations look a certain way, you can identify the slope just from the equation. But we're going to talk about how we can use sort of what we've been doing in our previous videos to find the slope of any line given any equation. Okay, so if we look at this first example, y equals 3x minus 4. And we want to find the slope of this line, all we really have to do is find 2 coordinate points that lie on this line in their xy parentheses kind of form, and then we can use exactly what we did in our last video, use our formula, do our subtractions, and find the slope that way, okay? So we looked at previously finding coordinate points for linear equations when we looked at graphing them. Remember, we made those tables of values, with x values here and y values here, and we did like -2, -1, 0, 1, and 2, and so on. So we're going to do something similar to that, though not exactly like this. I'm actually just going to create for myself 2 coordinate points, x comma y, like this, and I'm going to pick the x values, right? I'm going to get to choose the x values. Now, I think one of the easiest x values to choose is 0. Okay, is 0. And then another one that's pretty easy to use is 1. So what I do is I find y values then for each of these x values in this particular equation. So if I take the 0x value and I plug it in to this equation, it becomes y equals 3 times 0 minus 4. 3 times 0, of course, is 0. Minus 4, 0 minus 4 gives me -4. Okay? So I get that coordinate point, 0 comma -4, by plugging 0 into the equation. And then I can do the same thing with 1, plug 1 into the equation for x. So instead of 3 times 0, it will be 3 multiplied by 1. 3 times 1, of course, is 3. 3 minus 4 is -1. Okay, so I've created for myself 2 coordinate points, just like we saw in our last video. And now I can calculate the slope using my formula. So I'm going to take the 2 coordinate points that I just created from these equations, and I'm going to identify x1, y1, x2, y2, and I'm going to plug them in here. So the top of my fraction says -1 minus -4. Okay, so that's going to be kind of a tricky minusing negative subtraction stuff. And then because of the way I've designed this, x2 minus x1, 1 minus 0 is just going to be 1. So the bottom of my fraction is just going to be 1. So really the top of this slope fraction is going to tell me my slope, right? Because anything over 1 is just that thing. So if I look at the top of my slope fraction from these y coordinates, -1 minus -4 becomes plus +4. -1 plus 4, let's see, -1 plus 4, that's sort of like 4 minus 1, that ends up being 3. So my slope then for this equation equals 3, okay? Slope for that equation equals 3. So once I find my coordinate points, I just use my slope fraction to calculate the slope. Now, this gets a little bit trickier, a little bit more complicated when we get an equation that looks something like this. Okay, so 4x plus 2y is equal to 5. I'm going to do the same process. I'm going to find two coordinate points, and I'm going to use 0 and 1, again, as my x values. I'm going to plug those x values into this part of the equation for the x, multiply it by 4, and then try to solve for the y value, okay? So I'm going to plug 0 in there first. 4 times 0 plus 2y is equal to 5. Okay, now we have a little bit of work to solve this for a y. It's good, though, that 4 times 0 is just 0, and 0 plus 2y is really just 2y. So that equals 5. 2y is equal to 5. How can we then figure out what the y coordinate or the y value is? Well, we'll divide by 2 to get rid of the 2, and we end up with 5 over 2. So y equals 5 over 2. Okay? 5 over 2 is my y value here, 5 over 2. Okay, I'm going to leave it as a fraction, just like that. It is reduced. 5 and 2 don't have any common factors. And I'm going to try to find now my y coordinate for x equals 1. So I'm going to redo this process. I'm going to erase that. If you need it, you can obviously go back in the video and pause and write it all down. But I'm going to go backwards. I'm going to not do 4 times 0, but this time I'm going to do 4 times 1. 4 times 1 plus 2y is equal to 5, right? So I put the 1 in here. 4 times 1 plus the 2y is equal to 5. So now 4 times 1 gives me 4 equal to 5, right? So 4 plus 2y is equal to 5. Now I need to solve this equation for y. So the first thing I need to get rid of is this plus 4. All right, remember, we undo the addition and subtraction first when we solve equations. Minus 4. So we get 2y is equal to 5 minus 4 is 1. So now if 2y is equal to 1, I can just go ahead and divide by 2. That'll get rid of that 2 on the y. And what I end up with is y equals 1/2. Okay, y equals 1/2. So that's my y coordinate when x equals 1. Okay, now, like I said, this process is a little more complicated. It does involve fractions sometimes when our equations kind of look a little bit crazier and have numbers in front of the x and the y. But the process is the same. Okay, we find two coordinate points. Plug 0 in for x, find a y value. Plug 1 in for x, find a y value. Now I'm going to use my formula, which says y2 minus y1 over x2 minus x1 is my slope. This is x1, this is y1, this is x2, this is y2. So my formula says 1/2 minus 5 halves over 1 minus 0. Now again, the bottom of my fraction is 1 minus 0, that's just 1. So again, the top of my fraction is going to tell me the slope. Now here I'm subtracting fractions, right? But what is the good news about this particular example of subtracting fractions right here? Well, they have the same denominator, right? They're both the denominator of 2. So I don't have to do any work in terms of finding a common denominator. I can simply subtract the numerators here, right? 1 minus 5. 1 take away 5 is actually going to end up negative, right? Negative 4. And that's still over 2 as my denominator. Now again, as I mentioned, the over 1 here does not matter because of how I set this up. So this top of my fraction right there is my slope. But of course it can be reduced because 4 and 2 can both be divided by 2. So I end up with negative 2 over 1. Negative 2 over 1. That's just negative 2. Okay, so here we go. Negative 2 is the slope of this line. So when we have an equation and they ask us to find the slope, we can still use the method we had in our last video, and we can create coordinate points to use in our formula. Now, if we are given a graph of a linear equation, and if I draw myself a graph here real quick, if I'm given a graph of a linear equation and I'm asked to find the slope, okay, so let's say I've got this linear equation, and I put my arrows on it because it goes forever. Okay, it goes forever in both directions. If I have a graph and they ask me to find the slope, there's two ways that this can be done, okay? Either way, we need to identify 2 points on the graph that cross over the grid lines real perfectly, okay? Like 2 coordinate points that are whole numbers, nice number values, okay? So let's say, for example, that I can figure out from my graph that this point right here is 0 in the x, comma, 1 in the y. Okay, and then I also can locate a point up here that is, let's say, 5 in the x and 4 in the y. Okay, so I identify these 2 coordinate points from the graph just by looking at the graph, figure out, okay, where does my line cross over those little grid lines, those grid marks? Identify coordinate points on that line, and then I can go ahead and I can use my my slope formula, right? Because I now have 2 coordinate points. Sorry, that's a 2. And I can identify my x1, my x2, my y1, my y2. I can use my formula, y2 minus y1 over x2 minus x1. And x1, I guess in this case, is 0. I end up with a slope of 3 over 5. Okay? So we can still identify coordinate points from a graph and just use our slope formula that way. Now, if you would rather not do the subtractions, you can do it sort of in the graph as a picture. Okay, because remember when we made our ramp in the last video and we talked about the rise and the run? Well, we can do that in this graph as well if we identify our coordinate points. So from the point that's further to the left. In this case, which is this point right here, 0, 1, how much up do we have to go to get to the level of this point right here? How much up do we have to go? Well, that's really asking what is the change in the y, right? And so we can sort of count on our graph, how far up, how many squares up do I have to go to get from this point to this point, okay? So we count the up squares, and in this case, the up squares is 3, and then we count the over squares, which is like the run, okay? So then from this point over to here, how many squares does it take to get over to this point, okay? So we count over squares as well. In this case, that's going to be 5. Okay, now this is really doing exactly what I did here, you guys. I'm really just figuring out how far is it from 0 to 5, right? How far is it from 1 to 4? So on, but we can do it in a picture just by counting squares rise and counting squares as a run, and then make a fraction out of those. Okay, so our fraction would be 3 for our rise, which always goes on top, over 5 for the run, and again, we have the same slope, right? 3 over 5. So either way, from the graph, once you identify those coordinate points, you can either use your subtraction formula, or you can just count your squares for a rise and for a run and make your slope fraction that way. If you have any questions at all about finding slope or identifying it from graphs, equations, or coordinate points, please reach out to me and let me know so that I can do whatever I can to help. Otherwise, that's all I have for you right now, and we will talk to you soon.